Okay, so we're gonna start a new chapter now. So this is chapter 5, and it will mainly focus on functions. And again, this is very important. So chapter 5, 6, and 7 will be dedicated to functions. And this is kind of like what's really important for 20-1. Okay, functions plus factoring, which we already covered. These two concepts are, I think, very important because this is what you will see again in the future. Okay, so hopefully, with the remote learning, I think it will make sense because we're gonna go slow, and you will have those videos to access, right? So you can always pause, rewind, and do stuff like that. So I'm hoping that this will work out well for you. So for the starter question, it's just a simple question, right? So to understand functions, we need to understand relations. Okay, so they're kind of like tied together. So what I'm gonna ask you to do is I am going to ask you to just answer this starter question, pause the video. It's just a matching question. But once you do the question, I'm going to point out a few important things. Okay, so please do that. But obviously, I'm going to continue. So let's start off with so what we have to do is we have to match the fruits to the right color, right? So let's start off with apple. So apple, can either be red when it's ripe, or it could also be green. Okay, so it matches to two different colors. So if you only matched it to red, it's fine. I'm not gonna be picky, but there's a reason why I'm doing it this way. Once I'm done with the question, I'll explain that. So blueberry, right? Hopefully that wasn't too difficult. I think the word blueberry should have given away what the answer is, so that has to be blue. Cherry is also red. Um, I'm not sure, like when it's not ripe, maybe it might also be green. I'm not too sure, but let's just say red for simplicity. Banana is kind of challenging, right? Because there's no yellow, but it could be green, right, when it's not ripe. So let's just go with this, okay? So now this is a relation, okay? So there is a relation between fruits, right? And the colors, okay, represented by these arrows over here, okay? So this is a relation, but some of the relations are also functions, okay? But functions are very special though. It's a special kind of relation. This one is not, okay? It's not a function because we have a problem, okay? And the problem is the apple, okay? The apple, unfortunately, can either be red or it can be green, okay? And this is something that you cannot have in your function, okay? You cannot have, I'm going to use a fancy word, an element in the first set. So this is a set, okay? So this is your first set. This is your second set, if you want, okay? You cannot have an element, so an object, if you want, an element, right? Something in your first set that is associated to more than one thing. Okay, so it's red, but it's also green. So this is a big no-no for functions. Okay, so to understand this, right, let's just go over a few definitions. So definitions, a set, okay, a set is a collection of distinct objects. Okay, distinct is really important. So your objects have to be distinct. So that's why this is a set because the fruits are not repeating themselves, right? All the fruits are different: apple, blueberry, cherry, banana. You don't see apple appearing twice, right? So they're all distinct, okay? So this is a set. This is also a set because you have distinct colors: red, green, and blue, okay? So both of them are sets. Now, the second definition is element, okay? So element is an element of a set is an object in the set, okay? So an object in the set. So as you can see, this set, the first set has four elements: apple, blueberry, cherry, and banana, right? So I guess the objects inside your sets are known as um, elements. Okay, so red here is an element, green is an element, blue is an element. Okay, um, and one more, right? The fancy one, relation. Relation associates the element of one set. So relation associates element of one set, um, element of one set with elements of another set. Okay, so this is your relation. Okay, so we have fruits, right? They are associated using an arrow to the color that matches their description. Okay, now, right, we could have come up with a different relation, right? It could have been the weight, right? So maybe our second set could have been the weight because the fruits obviously weigh a little differently. It could have been you know the the area where they grow, right? The location where apple grows. So apple does not grow in warm places. Okay, it only grows in cold places. Um, and you have other fruits like maybe banana or something, and other tropical fruits like coconut and those kind of fruits. They only grow in warm places, right? So we could have our second set could have been continents or something like that. Okay, so we can always find a relation, but unfortunately not all relations are functions. Okay, and I'm going to talk more about that a little later. So what you can do is you can represent this relation using a table, right? In our case, we could have represent the relation between the fruit and the color using a table. That's fine. You could use an arrow diagram, which is what we did, right? You could also use a graph. Okay, so graph applies more to functions. So I'm just gonna ask you to add this over here. Um, and there's a reason why this only applies to functions, and then we'll discuss that again a little later. Okay, so this is how you can represent the relation. Okay, so some other important definitions. So I've highlighted this one in pink, right? Important definitions. So the first important definition: the set of first elements of a relation is called the domain. Okay, so the first set is what we call the domain. In our case, our domain was the fruits. Okay, so whatever was on the, usually like, oops, when you have a table, right? Then whatever is on the left is your first set, because we obviously read from left to right. So that's why, this is the first set, this is the second set. So this, guys, over here is your domain. Okay, and the second set is what we call the range. Okay, again, French immersion students, I think you guys have different words. So domain is the same. I think it's domaine, and range is image. Okay, in English we also call range image. Codomain is also another word that we use, but to keep things simple, let's just um, let's just stick to range. Okay, image could also be used. Okay, in French they use image. Okay, so again, they're just synonyms. Okay, anyway, so that's right. So that's why the starter question was, I guess, simple but important, right? So the set of related second elements is what we call the range. So in our case, it was the colors, right? The different colors. Now, see, I've put stars, right? So I've erased them just so that I can put it again for you. So function is really, this is an important definition. Okay, so a function is a special type of relation where each element in the domain is associated with exactly one element. So the keyword over here is exactly one element. Okay, so each element in the domain has to be associated with an element in the range, but exactly one. Okay, and one way of visualizing function is to think about the domain as students. Okay, this is just to help you out, and the range is their grades. Okay, so let's say students wrote a test. So I've just randomly chosen some students, and now what I'm going to do is I'm going to match the students to, let's say, the grade that they obtained, right? So we're starting off with Jessica. So obviously Jessica will probably get 100, right? Because she's very smart. She was even able to correct one of my mistakes, right? So a special shout out to Jessica once again. Thank you so much. um, and then we have Archer. I'm also placing myself in there because I'm hoping to do something silly. So Archer, let's say he gets 95. Okay, so Archer. And we have Keiko, and let's say Keiko also gets 95. Again, Archer and Keiko could have also obtained 100, but I'm just, I'm just messing around over here. And let's just say I failed the test. Okay, I got 49, so I failed. Now the question is this a function? Okay, um, and for it to be a function, each element in your domain set, right? So let's start with Jessica, should only be associated to one element in the range. And it kind of makes sense, right? So think about Jessica. Jessica cannot get 100 on the test and at the same time get 95, right? So that cannot happen, right? So let me be consistent with my colors, right? If it's something like this, right? Jessica getting 195, that is no longer a function. Okay, so and it makes no sense, right? Intuitively, if you think about it, right? So now, one thing that I'm going to point out, look, Archer got 95 on a test. Keiko also got 95. This is not a problem, right? A lot of students could get 95 on the test, um, right? But one student cannot get 95 and 100 at the same time. Okay, so one student can only obtain one grade. Okay, so this is a function, right? Because each element in your domain, be that Jessica, Archer, me, or Keiko, we only have one grade. Okay, so this is what it means, that each element in your domain is associated with exactly one element in the range. Okay, so for example, let's say if I add Zion, okay, Zion. So that's I really like that name because it reminds me of Zion Williams. But let's say if I have Zion in here, and then I have to associate Zion to one of the grades. Okay, I cannot just leave Zion like that because it says here in the definition that exactly one element in the range. So this has to get associated. So you cannot leave Zion by himself. So if I add Zion, let's say if he gets 100, then that's fine. Okay, so right, because Zion is only getting one grade. He's not getting 100 and something else. Okay, so if you add something in your domain, make sure that it's associated to something in the range. Okay, so this is what a function looks like. Okay, um, one element in your domain is associated to exactly one element in the range. Now that's not true for the range. Okay, that's not true for the range because as you can see, 95, the grade of 95 is associated to two different students. The grade of 100 is associated to two different students, namely Jessica and Zion. Okay, so that's not a problem. Okay, don't focus on the range, look at the domain. Okay, I hope that's kind of making sense, but we're going to do a few examples over here, a couple of examples, and I'm going to point this out, okay, very clearly. So which set of ordered pairs represent functions? Identify the domain and range of the set. Okay, so how do you find the domain? Remember, domain is your first set. Okay, so whatever comes first. So in this case, 1, 2, 3, and 4, they come first. So they will be part of your domain. Okay, so I'm just going to put D for domain, and I have 1, 2, 3, and 4 inside my domain. Now, whatever comes second will be part of your range. So 3, 6, 9, and 12 are part of your range. Okay. So 3, 6, 9, and 12 are part of your range. And as you can see, each element, right? Because you don't see one reappearing, or you don't see any of the numbers in your domain reappearing, right? In this question, at least. So this is and if you want, you can match this stuff, right? So I don't know. So let's just say, so 1 matches to 3, 2 matches to 6, 3 matches to 9, 4 matches to 12. Now this is a relation, right? There's a relationship between my set on the left and the set on the right, right? If you really think about it, the relation is each element in my left set gets multiplied by 3, okay? And that's how you get the values in your second set. But this is also a function. It's also a function because, as you can see, each element in my domain is associated with exactly one element in the range. Okay, so you don't have a situation where, let's say, 1 is equals to 3 and it's also equals to 6. Okay, you have nothing like that happening. Okay, so this is fine. So this is a function. Okay, so to answer the question, I guess what you could do um, is this a so what is the question asking? Identify the domain and range. Okay, so that we have done. So now, is this a relation? Okay, this is relation. If you have elements on one set associated to the elements on the other set, it will always be a relation. Okay, so as long as you have arrows, kind of like associating one element from one set, right, to the elements in the other set, it will always be a relation. But not all relations are functions. Okay, so is this a function? Yes, because each element in your domain is associated to exactly one element in your range. Okay, exactly one, not more than one. Okay, so this is a relation, but it's also a function. Okay, which is possible. But sometimes you might have a relation that's not a function, and that's basically what's happening over here. Okay, so again, the first elements will be part of your domain. Okay, so 1, 0, -1, and 0, they will be part of your domain. So let's use, let's be consistent, D for domain, and let's stick with the color red. So you don't have to do this, but I'm going to place them in increasing order. So we have -1, and then we have 0, but 0 is appearing here and here, right? So you don't have to put 0 and then 0 again, right? You don't have to do that. Only put that once. Why once? Because let's go back to the definition, right? The definition says that um, a set, right, is a collection of distinct objects, right? So once 0 gets included in your set over here, you should not re-include 0. Okay, so just put 0 once and that's it. Okay, and now for the range will be my second element. So I'm gonna just erase this to make some room for my range. So this is my domain. The second element is in the range. Second element is in the range. This is in the range. Okay, so let's label this R for range. And as you can see, it's exactly the same values, right? You have -1, and then you have 0 and 1. Okay, so -1, 0, and 1. Again, make sure not to repeat those elements, right? Because they're supposed to be distinct. And as you can see, there's already a problem, right? We didn't have to draw this out. The only reason why I'm drawing this out is because I wanted to show you what the domain and range are, but the problem is right over here. 0 is associated to 1, and 0 is also associated to -2. Now, I have an element in my domain, right? Like, namely 0, that is causing a problem because 0 is associated to two different um, um, values in my range. Okay, so let's draw this out, and I'll point out what the problem is. Okay, so -1, right, using this is associated to 0, and then you have 0 is associated to 1. Actually, you know what? Let me, because I'm gonna get confused. So I'm just gonna start from left and then go to right. Okay. So what's the first one? So the first one over here tells me that 1 is associated to 0. So let's do that. And then the next one tells me that 0 is associated to 1, and then -1 is associated to 0, and then 0 is also associated to -1. Okay, and this is the problem over here. Okay, so I'm gonna highlight this in actually pink. Okay, so that or not highlight. Okay, so this is a problem because this is kind of like if I said student 0 obtained two different grades on a test. He got a grade of -1 and also a grade of 1. Okay, so I know grade of -1 doesn't really make sense, but what I'm trying to show you is that this cannot happen. Okay, an element in your domain should be associated to exactly one element in your range. Okay, and over here the 0 is defying that condition because it's associated to two elements. Cannot be two. It has to be exactly one, right? Cannot be 0, cannot be 3. It has to be exactly one element. Okay, so to answer the question, right, is this a relation? Yes, it is, because you have arrows, right? You have there's a relation over here, a weird one. I don't know what the pattern is, but there is a relation because as you can see, the elements from one set are being associated to another set. Okay, so there is a relation, but it's not a function. Okay, because a function has to be a special relation where this stuff should not be happening, right? What you see in pink over here, this will not happen in a function. Okay, because you cannot have an element in your domain associated to two elements in your range. Okay, so this is not a function. So this is hopefully not a very difficult class. Maybe you've seen something like this in grade 9 as well. So I'm just gonna ask you to do these two questions for homework. Again, for question 4, I haven't specified what letters you have to do. So I'm gonna let you decide, right? If you kind of get this stuff, then just do maybe 1 or 2 questions from question 4, and that's it, okay? But if you need more practice, then by all means, you can do all of the letters. Now for question 5, only do C and D because I've done A and B for you in in the notes, okay? So I've already done that for you. Um, and I think that is it. So yeah, so this should not be a very long video, and we're gonna start off slow. Okay, so the key thing, the big takeaway from this video is to understand the difference between a relation and a function. Okay, so whenever you have two sets, right, associated to each other, it will always be a relation, but it might not necessarily be a function. Okay, it might not be a function, it might be a function. And there's a special condition, right, where it tells you that each element in your first set has to be associated with exactly one, right? So that's the keyword, exactly one element, right? So let's go back over here. This is the one, right? Exactly one element in your range. Okay, so if it's a function, then it has to satisfy this condition. Okay, so yeah, that is it, guys. Thank you so much. You have a nice day.